Good morning. We're going to be talking about atomic structure, and these would be our learning targets, and they look similar to the ones that we saw a little bit earlier in the Google Slides for the day. So, what are the components of an atom? What are the charges, mass, and locations of protons, neutrons, and electrons? So, that's what we're going to be covering here, and I kind of think that most of this will be sort of a review for you. You could have your best, no, you don't need your best friend right now. That's going to be the next set of notes. Okay, so let's go to the next slide. All right. There is a definition of an atom for you. So there it is. It's the basic unit of matter. And if you break it down, if you break things down and continue to get to smaller and smaller particles, you'll get down to this thing that is unique and has characteristics that will be the same for every other copy of it. So the atom is that particle that retains the uniqueness of an element. If you break an atom apart into its smaller pieces, then you don't really have an atom anymore. The cool picture in the lower left-hand corner, that is a whole bunch of silicon atoms that are lined up, and you can see the regular array of them, and then you can also see the one spot, if you can't see it. Oh, there's my cursor is right there on the spot where there's one missing. So that's kind of a cool picture. And so those are the outside surfaces of some individual atoms of silicon. Now, let's see. Which assignment was it? It was the POGL. We're looking at what elements are. And this is a lot like what an atom is, but an element is a pure chemical substance that can't be broken down into anything simpler. And sometimes when you break things down, you are left with an atom, and that is an element, and you'll have a whole bunch of identical copies. Or sometimes you have two atoms that are stuck together that make up some elements. Then there's like a couple other weird elements where you've got 5 of the same kind of atoms that are stuck together, but that is the fundamental particle that makes up that type of atom. So it says elements may exist as a single atom or as diatomic molecules. Yes, there's 7 diatomic molecules, but there's also one element that is 5 atoms that are stuck together. And then there's another element. The most fundamental particle of that element is 8 atoms that are bonded together. So there you go. There's elements. Molecule. 2 or more atoms stuck together. Could be the same kind of atom, or it could be different kinds of atoms. Now, when I look at this, right across the top here, those are just representations of different kinds of atoms. And yes, it's by color and a little bit by size also. And then these are the molecules down in here, and it's various combinations. And I can see some water in there. I see some carbon dioxide. I see ozone. I see methane. Let's see, what is that one? That looks like a couple of nitrogens. Anyways, it's a bunch of different molecules. And there's a couple of them that I can't identify exactly what they are, but that's okay. But I do know for sure that that's water right there. That looks like carbon dioxide. That looks like methane to me. That looks like ozone. And I'm assuming that the blue thing is oxygen. I'm assuming that the red one is hydrogen. And I believe that this yellow one is going to be representing carbon. So that's just some guesswork on my part. But those are some nice pictures. Pretty colors, right? Okay, moving on. Now, this is really cool. There's 2 main parts of an atom. There is the nucleus, that's the innermost part of the atom. And I think a lot of the time when you're doing the build an atom PhET simulation, a lot of the time you spent was looking at what's going on inside of the nucleus. And that's the inner part of the atom. And we'll talk about that in more detail. And the second part is the electron cloud. And that occupies way by far the most size of an atom is the electron cloud, and that's where you are likely to find electrons. And you can see this model over here. I don't know if you, hopefully you can see my cursor sort of making a circle over here. Each one of those little dots in there is just the probability of finding an electron. And when you see a denser pattern, you're more likely to find electrons there. Okay, so now I think we're going to talk about each individual part. Okay, first of all, there's the nucleus. Okay, that's where you have the protons, that's where you have the neutrons. Please understand that this is the part of an atom that has mass. So protons and neutrons have a lot of mass. Each proton and each neutron has a mass of 1 atomic mass unit, or a.m.u. And then there's charges that are associated. Protons are positively charged, and neutrons are neutrally charged. And it's kind of an interesting thing when you look at this, because protons have a positive charge. They're trying to get away from each other. And neutrons sort of act as a glue to hold the nucleus together. Now, something that we don't really get into that is really kind of important is the fact that protons and neutrons are actually made of smaller particles. They're made of things called quarks. And quarks are really kind of strange. In fact, that's one of the names of one of the quarks. But there's 6 different kinds of quarks, and the ones that make up protons and neutrons, and you don't need to know this. This is just kind of a cool thing for honor science students to know. But 2 ups and a down will make a proton, and 2 downs and an up will make a neutron. And so you can see this indication right here. Neutrons are 2 downs and an up, and protons are 2 ups and a down. Don't worry about up and down. That's just the classification of the kind of quarks that they are. Okay, so let's see. Nucleus. Oh, nuclei are also really, really small and really, really dense. And you're going to see that you probably saw that in the video about just how small is an atom. Now, the electron cloud, very cool thing. Now, look at the diagrams that you see at the bottom of the page. Each one of those is a representation of the probability of finding an electron, and it's all based on really cool math, some really high-powered calculus. And you see that these patterns are sort of like wave formations. And so that is one of the characteristics of the electron cloud, is that it is a probabilistic determination of where electrons could be, and it's based on a lot of wave equations. And so there you go. There's a bunch of pictures of what electron clouds will look like based on the orbital shape that each one of the electrons has. Now, you do need to know that electrons have a negative charge, and their mass is pretty much 0. They have some mass, but it's really pretty close to 0. Now, here's something for you to consider. Let's just think about a scale model here of an atom. Now, the nucleus is 1/100,000th the size of the electron cloud. So in a scale model, if I were to draw on the whiteboard in the front of my classroom a nucleus that is 10 centimeters in diameter, 10 centimeters in diameter, that means that the whole diameter of the atom, when you include the electron cloud, would be 10,000 meters. 10,000 meters is like a diameter of about 6 miles. So the radius would be 5,000 meters. And when you look in the 4 directions from Eden Prairie High School and you figure out what is about 5,000 meters away, if you go to the east, you go to Home Depot. If you go to the west, you go to Chanhassen and the Byerlys. If you go to the north, you wind up at Excelsior Boulevard. You go to the south, you wind up at Flying Cloud Airport. So basically, just think of that size, that scale model, where if you've got a nucleus that is just 10 centimeters, and then you go in those 4 different directions, roughly 5,000 meters in each direction, that's huge. I mean, that's there. And by the way, there's nothing but like 8 electrons. If it's an atom of oxygen, you've got 8 electrons that are occupying that space. So now here's my Oh, this is kind of a sad thing to say, but next time you're kind of feeling sad, you're kind of feeling down, you're thinking like you're nothing. Guess what? You're right. Because atoms are mostly nothing. They're mostly empty space. And because you're made out of atoms, you're mostly empty space. Now, there's the happy thought for the day. Okay, this tree map. This tree map is something that you're going to be doing today, a little bit later. So there you go. I'm just going to stop right here. I think that's about it. If just as a reminder, if you have any questions about anything, please go ahead and let me know. Shoot me an email. And I do have to apologize about the synchronous and asynchronous. There's a policy change that the high school made. And so all the stuff needs to be asynchronous. So anyways, we'll do our best. And I hope I hope to try and keep these things interesting. And we'll see you later.